All right, today we are diving into something that can feel incredibly complex, the immune system. But we're going to make it simple. How? By forgetting the biology for a second and thinking about it like an epic defense strategy for a nation under siege.
So let's start with this big idea. Your body isn't just, a bunch of cells and organs. Picture it as a huge, bustling country. It's got borders, infrastructure, and a massive population of citizen cells. And just like any country, it's got enemies and it has to be defended. This one idea, this analogy, is going to be our key to understanding everything.
So who are these enemies? Well, you've got two main kinds of trouble. First, there are the external threats. Invaders trying to smash through the borders. We're talking bacteria, fungi, that kind of thing. But then you've got a scarier problem. Internal threats. Traitors. Citizen cells that have gone rogue. Maybe they've been infected by a virus or have turned cancerous. They're trying to tear the country down from the inside.
So how does any good defense begin? Not with guns blazing, that's for sure. It starts with information. It starts with intelligence. So how does our body nation even know it's being invaded? Well, it all kicks off with its incredibly sophisticated network of intelligence agencies. In the science world, we call these spies antigen-presenting cells, or APCs for short. Just think of them as the CIA or MI6 of your body. Their job isn't to fight the war themselves. No, their mission is way more critical. They gather the intelligence that allows the army to win it.
And this isn't just one agency, it's a whole network. You've got your dendritic cells, who are like the elite field officers out on the front lines, actively hunting for threats. Then you have macrophages. They're kind of like the local beat cops and forensic units, cleaning up crime scenes and analyzing what the bad guys leave behind. And then there are B cells, who act more like the data analysts back at headquarters, piecing all the intel together.
Okay, so with all these spies and soldiers running around, how do you prevent chaos? How do you stop friendly fire? Well, the country has a foolproof national ID system. It's called the Major Histocompatibility Complex, or MHC. Basically, every single cell in the body has to constantly show its ID card, no exception. And here's how it works. Your normal, healthy citizen cells are constantly taking little pieces of what they're making on the inside and displaying them on the outside using a platform called MHC Class 1. It's their way of saying, hey, I'm a loyal citizen. Here's a sample of my work. Everything is normal in here. It's a continuous, routine security check. But our intelligence agents, the APCs, they use a totally different platform, MHC Class 2. See, after they catch an invader out in the field, they break it up and display a piece of it on this other platform. So their signal isn't, here's what I'm making. Their signal is a red alert that says, attention command, I'm a loyal agent, and this is a piece of the enemy I just captured.
So, the spies have the intel. Now what? You can't just launch a full-scale war based on one report. Getting the green light for a military response is a whole other process, and it has to be done with extreme care.
I mean, really think about that. An army can't just act on its own. That would be a recipe for disaster, for civil war. You absolutely need a specific, multi-step authorization from the very top of the chain of command before you deploy a single soldier.
And this authorization is like a three-key launch system to prevent mistakes. The generals of our immune army, the helper T cells, need 3 signals before they'll do anything. First, they have to see the intel for themselves, the enemy piece on the MHC platform. Second, they need a safety check, basically a secret handshake to confirm it's a real threat and not a false alarm. And third, they get the final go order through secure messages we call cytokines. Only when all 3 happen is the attack authorized.
Okay, the order is given. The green light is on. And now, the defense system launches a war on 2 separate fronts. The first wave isn't about fighting in the open. It's about dealing with the traitors, the enemies hiding inside our own city walls, inside our own cells.
For this job, you send in the elite commandos, the cytotoxic T cells. These are your special forces. They are trained for one mission and one mission only. Seek and destroy any of our own cells that have been compromised by a virus or have turned into cancerous traitors. They are the experts at handling internal rebellions.
So how do they do it? They patrol the country, checking the MHC Class 1 ID on every cell they meet. If they find a cell that's flying an enemy flag, displaying a piece of a virus, for example, they lock on. Then they deploy this incredible 2-part weapon. First, they fire perforants, which punch holes in the bad cell. Then, they inject granzymes through those holes, which is basically a signal that tells the cell to self-destruct. It's a clean, surgical elimination.
But what if a really clever virus or cancer cell just decides to hide? What if it stops showing any ID at all, just rips its MHC class 1 display right off? Well, the immune system has a plan for that too. That's when the natural killer cells, or NK cells, get called in. They are the rapid response team, and their job is simple. If they find a cell that's trying to hide its ID, they take it out. No ID, no questions, you're gone.
Okay, so that's how we deal with threats on the inside. But what about all those invaders running around in the open territories, like in the bloodstream or the tissues? For that, we need a completely different branch of the military.
This is where we move from special ops commandos to advanced weapons manufacturing. This branch is built around the B cells. And if T cells are the soldiers, you can think of B cells as the country's most high-tech weapons factories. They can design and mass-produce precision-guided weapons on a staggering scale. So once one of these B-cell factories gets that authorization signal from a helper T-cell general, it's like a switch is flipped. The whole factory transforms. It becomes something new, called a plasma cell, and it now has only one job: churn out millions upon millions of guided missiles, which we call antibodies. And these guided missiles are unbelievably versatile. They don't just blow things up. They can fly out and neutralize toxins directly. They can stick to invaders and paint them as targets, making it easier for other cells to find and eat them. They can even activate a separate bomb squad called the complement system. It's an amazing multifunction weapon.
So the war is won. The invaders are cleared out. Is that the end of the story? Not even close. Because a truly smart defense system doesn't just win a war, it learns from it. It makes sure it can never be caught by surprise by the same enemy ever again.
This whole process is called immunological memory. See, after the fight, some of the veteran T cells and B cells don't just disappear. They stick around, becoming memory cells. They form a living, breathing national archive of every enemy the country has ever faced. They can patrol for years, even a whole lifetime, ready to sound the alarm instantly. And right there, that is the entire genius behind vaccination. Because a memory response isn't just faster, it's way, way stronger, sometimes hundreds of times stronger than the first time. So a vaccine is basically like giving your archives the enemy's battle plans. You get to train your entire defense system for the real war without ever having to suffer through the first bloody invasion.
You know, when you finally step back and look at the whole picture, it is just breathtaking. From the spies gathering intel, to the generals demanding a 3-key authorization, to a perfectly coordinated war on 2 fronts, and then creating a living archive to remember it all, every single piece works together in this beautiful, intelligent network.
But that does leave us with one last nagging question, doesn't it? If our national archives are so good, if our memory is so effective, how come some enemies, like the flu virus, seem to get past our defenses year after year? Well, that's a story about enemy spies changing their disguises, and that's a topic for another time. Thanks for joining.